In the last video, we talked about the comparable interface over the employee class. So one thing that we said was that we can put these employee objects into a list and then sort the list, and it will sort it based on whatever order compared to uses. So, or rather, what it does is the sorted method will receive a stream or operate over a stream, and it will sort it based on the natural ordering of the uh, of the type, right? And the natural ordering, like we said, is just the fact that it implements the comparable interface. Okay, but what if we want to change the metric at which employees are compared? So, for example, right now we say that the lowest salary comes first, and if the for example, if the salaries are the same, then we compare it based on the name. So in the output here, we have Jack comes first, then Owen, then Gilmore again, and the order of these doesn't matter because they're basically the same object. And then Joshua comes last, and even though that Joshua and Gilmore make the same salary, the comparison metric says that if they have the same salary, then we compare them based on the compare to of the name. Okay? And that's just the lexicographical comparison. So, with that in mind, like I said, what if we want to change how we compare them, how we compare employee objects? Well, all we have to do is change the compare to definition, right? So, like, what if we want to, for example, say that people who have less salaries come after, right? You know, we just want to essentially reverse the order, okay? And for example, we could flip this comparison to say that, people with people whose names come later in the alphabet actually come first in the ordering, but that doesn't matter. So the main thing is that we want to reverse the ordering of the salaries. The problem now is that any code that relied on that previous implementation of compare to is now completely broken, right? Because we just changed a core definition of employee, and now all other code, including this one, that relies on that old implementation of compare to, is now just completely useless, and it doesn't work. It doesn't work correctly, at least. And, some other code that may have been written that relies on that assumption now doesn't work, or at least now can't be guaranteed to work. So, what is the solution? The solution is actually something that we've seen before. It's something called not this, because I just didn't change it. It's something called a comparator. Okay? And we've seen comparators before. We've seen them when we talked about priority queues. Comparators are just ways of packaging the behavior of how we compare two arbitrary objects. And then that object can then be passed to other methods that use or operate over an ordering for some object. So, what does all that mean? That means that we can create a new class. So let's create a private and static class. So what do we want to do? We want to say that there's some natural ordering for comparing employees. And we'll just say that natural ordering is the one that we defined in the previous video. That lower salaries come lower in the ordering, and if they're equal, then we compare based on the names. But what if we want to define another comparison metric for employees? Well, we can use a private static class. Or actually, this probably shouldn't even be a private class. It can just be a static class. Static class. Let's see. So what do we want this comparator to do? Or what do we want this new ordering to do? We want this new ordering to have the salaries in reverse order. So higher salaries come earlier in the ordering. So we'll say high to low salary comparator, and it implements the comparator interface, and we pass it employee because we're saying that we want this class to represent a comparator that operates over employee types, okay, or employee objects. So, fortunately, this class is very simple. All we have to do is implement this one method. This one method, as we've seen before, is compare. Just compare. And remember that we said that we have to use public here, and that's just because, well, now we know that comparator, or rather compare, the method, comes from the interface comparator. And because of that, we have to make it public, because all methods from interfaces are implicitly public. Okay? So, compare receives two objects of the type that we specify. And for, just as a reminder of how this works, it returns an ordering of O1 with respect to O2. Does that sound familiar? It's exactly how compare2 works. So this returns an ordering of this instance of employee with respect to O. Okay? This one, it just takes in two objects of type employee, and it will return an ordering of O1 with respect to O2. Okay, so what do we want to do? We want to say, if O1's salary is less than O2's salary, then O1 should come later in the ordering. Okay, and one thing I'll note again is that it may seem a little weird to be using these instance variables of employee when we're not even in the employee class, right? Well, we are in the employee class. We're just inside of a class that's defined inside of another class, okay? So, but in my opinion, I like to use getters even when we're inside of a private or a non-private, inside of inside of an inner class or a class that's defined inside of another class. I like to use getters just because. You don't have to, and there's not going to be a performance difference. It's just something I like to do. Okay? So, if the salary of O1 is less than the salary of O2, we will return 1. Because we're saying that we want this to come after O2. And remember that compare returns a negative number, a positive number, or 0 if O1 comes less than O2, or comes before O2, if it comes after O2, or if it's equal to O2. Okay? So, we return 1 here. Now we're going to say if O1.getSalary is greater than O2.getSalary, then we want to return -1, because this ordering will now come, or O1, if it has a greater salary than O2, it will come before O2. Okay? And if they're equal, we'll just use the same metric as we did before. So, and what that means is we'll just use the name comparison method. So, what we could do is say, return O1.getName.compare to O2, but or O2.getName, sorry. But what we could also do is just say return O1.compare to O2, because .compare to will call this method, right? And it'll run through these two checks and see if they're false, and then it will jump down to this comparison, okay? So these checks are kind of, in this case, they're kind of redundant, but it's, it's not going to make any difference in the long run, okay? So you could say, this could be return O1.getName.compare to O2.getName. Either one is perfectly fine, okay? So now, how do we actually use this? How do we use this comparator object? Well, we could pass it to some ordered data structure, like a tree set, a tree map, a priority queue, or we can do something like this. We can say, if we have so the order that I'm inserting these elements is actually just in some arbitrary order that I chose, and it doesn't matter. When I wrote these, I just so happened to pick, ascending just by accident. But the idea is if I insert them randomly, hopefully you can see that it's not going to, the order that I insert them doesn't matter. They would be sorted by the sort method, and that would work. Okay? So But how do we tell Java that we want to sort this list with respect to not its compare to method, not employee compare to method, but rather this comparator? Well, like I just said about a minute ago, we could use a ordered data structure, or we can use this method called collections.sort, which receives a list, and it receives a comparator object. So we say we want to create a new instance of the high to low salary comparator object. Now, under the hood, this will sort the list ls1 with respect to this comparator. So this is how it will compare objects. Now notice that if we don't pass it a comparator, it will rely on the natural ordering of the object, right? And remember, the natural ordering is just the comparable interface. And even the documentation of this says if we don't pass it a comparator, then all elements in the list must implement the comparable interface according to the natural ordering of its elements. Okay, so now this, you should note that collection.sort mutates this list. It mutates the list. It doesn't return a new list. It actually mutates this list in place. So if you're going to use list.of, you have to wrap it inside of a new array list constructor, because this will take all the elements from this list and put them into a mutable array list. So if we run this now, it should be in this order again, or actually it should be in the reverse order because I'm not passing the comparator. So let's just see what happens if I do that. Indeed it is. But now if I pass the comparator object, the new high to low salary comparator, now it should be the reverse, and indeed everything works as expected. So comparable and comparator are really, really, really important interfaces, and they should not be conflated with one another. They absolutely each have their purposes, and most of the time when you're implementing a class, you'll probably implement one or the other. Usually you'll implement comparable just by the nature of wanting to probably sort or order your objects. But if you want to then provide other orderings for that object, then you'll need to implement a custom comparator object.